Hi. Got another part here from James Condon for a project he's working on. This is for something he's working on with a Kawasaki motor. This is an intake manifold that he needed to replace. I don't think he was able to get the exact one he needed, but he found this part. These mounting features in the casting are 19 millimeters tall, but they are 2 millimeters too close together to match the hole pattern in the engine block or head. These are for M5 fasteners, so these current holes are about 5.5 millimeters wide. Running an 8 millimeter drill bit through here would open them up sufficiently to elongate the pattern by 2 millimeters. However, James was hoping for a clean solution that also wouldn't risk coming through the inside of the casting or thinning this out unnecessarily. If an 8 millimeter drill bit went through here, freehand or wandered or anything, he was concerned maybe it would risk being too thin or impacting how this fits up long term. So he sent it to me, asking if I can mill an ovalized slot in this to elongate each hole by 1 millimeter, giving us an oval pattern that should mate up to the pattern on the engine. Very straightforward. The hardest part is going to be figuring out how to hold this without getting in the way of what we're doing. Just clamping across the top would be the most straightforward. However, I'm not sure whether we would be able to do that without getting in the way of the mill. So maybe we'll try that. Maybe clamping down on these features here, but they're not quite flat. They have a bit of a kind of draft angle to them. Of course, it's always important to have as rigid a setup as possible. It's especially important here where we have a narrow tool cutting through this long feature, where if the part comes loose, we probably will break the end mill and we may damage the part, possibly to the point that it is no longer usable. Similarly, instead of putting the end mill in and just directly moving in this direction, we don't want all that tool pressure across the cutter. It would make more sense to plunge the end mill in the position we want and then run it backwards to remove the scallop of material that's left behind the cutter. So we'll move over to the mill. We'll figure out how we want to set this up to get the rigidity that we need, as well as the clearance to allow the end mill to come out the bottom of the part and move around a little bit. I've been at the mill for a few minutes thinking about this, and I wanted to make sure to think about the simple options first. Putting the part with its one machined surface flat down on the table would certainly make getting it in a flat plane easy. But as we talked about at the bench, there's just not enough meat to clamp on here. To feel secure about this, we would need probably 2 clamps on each side, so one like I have there, one here, and then the same on the other side. And that's going to make it really tight to work in the space between the clamps. I'd want to have at least 3 clamps on it during the work. I'd probably remove the front one on the side I'm working on, put it back, and then remove the front one while I'm working on the other side. But I don't trust that not to move. And when I bring the quill down, the end mill I'm working with is not able to reach all the way down and through the part and a little bit more without the collet chuck and the spindle hitting this part. It would all be very tight and uncomfortable. In this setup, we would also need to mill, probably clamp down an aluminum plate onto the mill, take a pass to clean up the top of that, and then clamp this onto that. That way we can run through into the sacrificial plate underneath. I'm not a fan of this option. I did notice, though, you can't see it on camera, but it rocks a little bit. There is a burr around the edge, a lot of the edges of this part. I doubt that was there after machining. The burr would have been folded down for machining, but I think just in handling it since then, it's gotten dinged up a bit. So either way, I'll clean that up before this gets sent back. Probably clean that up first, because I think the best option, or the necessary option for mounting this, is going to be holding it with this side up. It's not going to be as easy as if that all worked out, but it will let us indicate across this to make sure we are holding it flat. It'll give us complete access to the face of the part. We'll be able to bring the quill down nice and tight, however far we need to come through this. The question is what goes behind this to support the part. We could make some kind of sacrificial aluminum block for this to sit on and mill out a whole bunch of material in the middle. I think there might be a more simple option without having to make all that. What about using the mill vise? Well, these 1/8 parallels could sit inboard of the holes here. If that's true, the part could sit in the mill vise, and given everything else I said about needing to take light cuts and reduce tool pressure, we might be okay with some minimum clamping on this. That's more solid than I expect without even putting much torque on the vise screw. So if we can just put some material between the vise jaw and the parallel to ensure it doesn't wander into the space where the end mill is going to be, we potentially could work just like this. We would need to take some time to line the part up so we are moving the tool exactly in the y-axis of the machine. But this looks like a even simpler and more straightforward option than having to make any kind of sacrificial material for the table. Once we have this aligned to the machine, it's possible we can just take the parallels out and leave it unsupported, given that we will do everything we can to reduce tool pressure and deflection on any parts. So with the part tapped down onto the parallels and the vise clamped, we're actually just about within 1/1000th of being level. The reason it's so important to have an easy way to get the part level is because every time we want to adjust this to put the two holes in the y-axis of travel for making the oval slot, we have to unclamp the jaws and move things around or tap things around. And if we didn't have an easy way of keeping it level, we would end up taking it out of level or out of square every time we made a change. So now the question is, how would we want to get centered up on those holes without having to center find each one and then try and move the part, try and rotate the part looking from the top without moving one side or the other. We might be able to get away with pushing one end or the other of this router centering tool into the part and go back and forth and push into them, only moving the y-axis of the table until it's centered up. This is, I think, a work smarter, not harder situation where we don't need, if the ovals are a couple thou out of plane, it doesn't matter for what this is. We want to do an appropriate job, and ideally the cleanest and most precise job we can, but killing a bunch of time going back and forth and getting this to under 1 thou or down to a couple tenths is not worth it for what this part is. Well, that's nice in theory. However, the reality is that the back of the casting where the fastener heads clamp is not machined and doesn't sit level on the parallels when the part is squared up with the holes aligned to the y-axis. So I did end up spending the aforementioned bunch of time going back and forth to have the plane of the part, the top of the part level, and the holes aligned to the y-axis using the router center to visually check. So it was 4 different things that had to be checked and get them all in mesh with one another. Level in the x and y axis, and then having each hole aligned to the y travel of the machine. After going back and forth a bunch, we had the face level within under 1/1000th of an inch, the holes lined up, and we were ready for the next step of the project, which is to make a bushing to allow us to hold the 5mm end mill in the imperial-sized collets for my mill. So we'll head to the lathe and make a brass bushing to hold this. Let's make a bushing. Gonna just clean up the outside diameter. It's 3/8 nominally now. We'll skim it, face it, put a hole down the middle, part it off, split it, clean up the burrs, and then see if it gets something usable for us. Alright, clean this up a little bit, hold it and slit it, see how it does. I went ahead and slit the bushing with a hacksaw while holding this between two blocks of wood. To use the bandsaw, I would have needed to really hold this with vice grips, and I didn't want to risk distorting the soft material and ending up just getting more run out as a result. So I've got it split, cleaned up the burrs. I tested it in the collet. It's got a little more run out than I'd like for other operations, but being that we're mostly doing a plunging cut instead of a side cut, and this is on a soft material, I think it's going to be okay. If it acts worse than I like, then we'll wait for a 5mm R8 collet. I've got this lined up from earlier with the center. My zero on the DRO is in the middle of the front hole. We'll go center up on there with the 5mm end mill. Come 1mm towards the camera, which is about 40 thou for what we're doing. Then we'll move back, do the same in the back, and move 40 thou away. So I think we'll end up going a few thou left and right. Right now it's not quite an oval, it's a bit pear-shaped. So I'm going to come back in. Maybe I'll plunge in 5 thou, this to the left of center, see how that looks. Alright, I like how that looks a little better. Double check. Alright, now we'll go back our 40 thou, 1.404, we'll plunge. And that should be it. All that prep work for like 3 minutes of actual milling. Alright, there's our ovals. The parts I machined are a little narrower than the originals. The originals were closer to 6mm on one end or the other with the taper inside. But it's an M5 fastener, and I opened it up an extra 20 thou across the width. That all went pretty well. I'm happy with the result. The holes are nice and clean inside. No issues with the rigidity or deflection in the cutter or the run out that was on the cutter with that split bushing. But while taking measurements, preparing to record the summary for this, I realized I made a mistake. It was the good kind of mistake where we removed too little material instead of too much. So I fixed it off camera, but let's talk about it. Originally, these were holes meant for a 5mm fastener, and the part came with clearance holes around 5.7mm in diameter. The stated goal was to expand the outside dimension of the pattern, so outside hole to outside a hole, by 2mm, or roughly 80 thou. So we started out with 2 holes on a 1.364-inch center, which gives an outside to outside dimension of 1.588. On the first pass, therefore, we dropped into the center of each hole and moved our cutter outwards 40 thou, hypothetically giving us this roughly 2mm increase. However, that was if we had a 5.7mm cutter or a 5mm cutter starting against the outside of the hole, not the center of the hole. So that ended up giving us an outside to outside dimension of 0.641, shy of what we wanted, which was adding 78 to 80 thou. So off camera, I set the part up, which didn't take too long, and took another pass, bringing us out to the dimension of 1.668. So basically I went 15 thou out further on each side. 55 thou from the center, or 40 thou from the original edges. So, now the part is ready. It has the ovalized holes we were looking for, deburred on the top and bottom. We'll get it in the mail with the other 2 carburetors I just finished repairing for James. This will let him finish his project. We'll see how it goes. Thanks for watching. You'll see me next time.